this video, I want to cover some really cool stuff that I've had a chance now to play with. One of the things that Chrome and Edge browser as well are offering are built-in LLM, local large language models. The Chrome browser is using Gemini Nano, and it has a series of APIs that you can see the status of. At this point, the summarizer, the language, and the translator API as of Chrome 138 right here are good to go. Now, you do need a computer that can support this, and there's some recommendations here for the hardware. I'm running a newer laptop here, and it is an Intel Core Ultra 258V. It has 32 gig of RAM, and it has a built-in, I guess, GPU in that regard. It's not technically a full GPU, it's an emulator, but it gives me more than enough power, as well as the Intel Core Ultra actually being a chipset that has a neural processing unit as part of it. So please check your computer specifications to see if this is going to work for you. Now, another way that you could test this out very simply is if you go to the developer.chrome.com, Docs AI Summarizer API, and you open this in your Chrome browser, 138 and higher, and you put in some type of a prompt. So you can just copy some text here. If you see red here, your machine won't support this, then it's a no-go. But if you have the ability to put some text in, you'll see that it'll eventually generate a summary for you. There it is, based on what you put in. So that means things are working for you. So this was really nice just to say, hey, your machine's going to work for this. So super cool. The documentation, the code, how you can approach this, they've done a wonderful job of showing that, and you literally can copy paste and start to build something. Well, I've done that, and also with the help of this GitHub site, which is super great, from this fellow here, I believe Ellis is the last name. You can actually enable even more of still what's kind of behind the flags for like prompting and such. So this GitHub URL here taught me a bunch. The summarizer and the prompt API, the documentation here is great. It definitely covers the nuts and the bolts, but the real key then is trying it out, and that's pretty much what I've got here. So let's start with this example. Now I'm running this off my hard drive. This is not hosted anywhere. This is completely on my hard drive, my C drive. I'm on Windows. I'm going to refresh this page. So I did a little check first in my code, and I said, hey, do we have the summarizer available to us? And sure enough, that little Sweet Alert prompt, it's the original Sweet Alert, by the way, not Sweet Alert 2, comes up and gives me a nice little, you're good to go. So now I'm going to browse for a file. So here I've selected a file from my hard drive, and again, I'm running this locally. And one of the things I want to show here is that there's no network traffic that's happening here. This is really important to understand. This is truly local. So now by selecting my document, and it could be a PDF, the format is immaterial at this time. I've chosen to work with DocX because that's how I wrote this page. But I could have worked with a PDF as well, or other formats. It depends. And now I'm going to do this upload. So again, another Sweet Alert prompt, but do we see any network traffic here? Do we see anything happening that is telling me, well, there's a fonts static thing, but that's nothing. And in about 15 seconds, it just gave us a summary. This is Gemini Nano running locally using the Chrome Summarizer AI API. Now what you can see over here is some of the output of my code a little bit, and none of this is magical. It cracks the file and extracts the text, and then it sends it off to the JavaScript. Now this downloaded bit, well, that's the actual model. So the model needs to come down to your machine. But other than that, there's no phone home code here. There's nothing happening back to a server somewhere where that is being run. This is being analyzed, summarized on my machine. And I was able to detect with this flag here, Chrome / on device internals, it tells you where it drops the model. Now again, this is Windows, so app data. So there's your model. And it gives you the name of the model, the version. It gives you some information about your computer. And it gives you the ability to even potentially set some flags if you needed to. I've already enabled the flags that I wanted, but it looks like maybe there's even some more things to come here that we haven't even heard about yet. So that's super cool. But this is where it's reaching inside the innards of the Chrome browser to grab the model and use the API to work with it. Super cool. Okay, in this example, we just refreshed and we can see now that language model has been instantiated. There is a big difference there. The summarizer is its own entity. It's its own object. Whereas the prompt, so you see summarizer availability, summarizer create, whereas the prompt is actually derived from language model. So that's a little bit of an interesting find. It doesn't super make a difference, but if the language model isn't available, then the prompt API is not going to work for you. So that's something just to take into account. So with our other example here, we're going to pick a file. And as you can see, I've chosen the exact same file as the prior one. Okay? I want to do that because I want to show the difference now as to what's going on. Let's inspect and let's look at our network traffic and let's upload. So here we see the extracted text. Okay? And now it's processing. But in this instance, instead of just sending this to a prefab summarizer, I gave it a prompt. And the prompt I gave it is, please summarize the following information. That's it. That's all I gave. And I put that right before all the extracted text. That's the extent of my prompt. Please summarize the following information. And I think it'll be very intriguing to see what the output looks like here. So it's ripping through this, it's using the prompt API to do this, and it's taking a little bit longer. I haven't seen it run this long, but here we go. This really broke it out. And if we do some comparisons here, we've got all of 90 words here with 15 seconds, and we've got 284 words here with about 50 seconds. So this is super interesting. It's taking it and it's giving us a breakout of what's going on in the document, and it decided to handle core process. It decided to talk about architecture and data flow. It decided to talk about key points. This is from that very simple prompt. Now what's also interesting is the output. All right, so we see here a bit of an attempt at some formatting, maybe even some markdown concepts. But at the end of the day, that can be grabbed before rendered, and you can then turn that into headers. You could turn that into whatever you want. The next steps, which I'm not going to cover in this video, but probably in a future one, will be, can I actually do something with retrieval augmented generation? My guess is yes, but I want to really make sure before I say it's possible. but I don't see why it wouldn't be. So here you have an example of a local large language model, Gemini Nano, running on a relatively newish laptop. But again, I think if you're from the Mac variants, you know, the M3 and the M4 chips seem to work, but your mileage is going to vary there. I have been able to see this work on a different Windows Intel Core i7 that had a little bit of pseudo GPU to it. But obviously the newer the device, the better your chances are this is going to work. And maybe they'll be able to backport it, even for older machines. Not really sure on that front if that's going to be possible or not, based on the need for using transformers for how they're handling large language models at this time. But this is the prompt API, this is the summarizer API, and you can see running locally on my device and offering me no phone home. Everything stays on device, everything is kept private, and I have the ability to take a look at it. You can see here I swapped the asterisks out for emojis. So that's an example of what I was talking about here, where you could just go with what the output is this way, find that and do what you want with some search and replace in JavaScript, not a big deal there, or alternatively attempt to use retrieval augmented generation to really craft how you want your output to be. So I hope this was at least a little bit of a helpful insight into what's available today within the Chrome browser. I believe the Edge browser is also supporting, I'm not sure the model, and a lot of great stuff to come now with the ability to run models locally in your own browser privately. Thanks.